Hello, Year 12s. All right, unit circle, how to memorize. Okay, the unit circle, the circle of one unit. Unit, as in one, circle. This geometry with circles goes back a long way, well into antiquity. You can imagine it's quite easy to draw a circle. I've got a piece of string, right? I hold the middle, I pull it round, and I can draw a circle in the sand and, start doing my mathematics. You can start doing what are fairly basic operations like, for example, there's a line. Imagine I want to cut that line exactly in half and I don't have a ruler. You could do it with circles, right? You could say, well, I'll draw a circle from that end, like this, and then I'll draw a circle the same size, same bit of string from this end, and I'll see where they cross, join that up, and now I've got a perpendicular bisector. So I've cut the line in half at exactly right angles. Right? Now that's a pretty easy one, but there's all sorts of geometric constructions that you can do with circles, and there's a lot of interesting mathematics. I'm blanking on this. I think it might be the Mesopotamians, maybe the Sumerians. It's before the Greeks. Don't think it was the Babylonians. I think it predates that. But the idea of the circle starting over here is because the sun rises in the east and it sets in the west. And what were ancient civilizations really interested in? Astronomy, right? Understandably. And they didn't live in cities with bright lights and they could actually see the stars properly. And they probably knew more about the position of the stars than you or I, because they would have been out there gazing at the sky. And you can too. But anywho, so that's our circle. Now, at this point, I have done no memory work at all, right? This is on a Cartesian plane. Nothing to memorize yet. I've just got my X and my Y. I know it's a unit long, it's one long. And so I'm drawing those points on. I know what the coordinate is here because I'm in negative Y's and the X is just 0. Easy, easy, right? Now, there's only 3 angles that we really look at. Try and draw them with a bit of accuracy. No, who am I kidding? Well, won't be too bad. Right, there we go. And we're year 12s. We know that there is pi on 6 radians. That's pi on 4. That's pi on 3. Where does this radian measure come from? Well, if pi is the distance around the circle divided by the distance across the circle, right, then the distance around the circle is pi times the diameter. I don't know, is it a capital D? I can't remember. Or little d, I should probably know that. I'm going to use a capital D. I could also say pi times 2 times the radius, right? Now in our unit circle, we just went and made that radius equal to 1. So we've got 2 pi as our distance around the circle. And we also have 2 pi radians, right? Halfway is pi, etc. So if halfway is pi, this is 1/6 here. Pi on 6, there's a quarter, pi on 4, and there's a third. And those are the angles we remember because they work out to be nice, easy numbers to remember for sine and cos. Whereas the other ones, there's, lots of decimals, that type of thing. So these are the ones, these are our go-tos, if you will. Now, I remember, this is my starting point. So I have a starting point. This is my method for memorizing. And it's sine, right? The y coordinate is sine. Maybe we should stop and think about that for a minute. Why is the y coordinate sine? Well, how could I get to that coordinate? I'd need an x length there, and I'd need a y length. Now, sine is the opposite over the hypotenuse. Hypotenuse is just 1, so that's why my y is sine. And x is the adjacent, right? So that's why the x coordinate is the same as cos, because cos equals adjacent divided by hypotenuse. Okay. Now from this point, I go 1, 2, 3. But first, everything that's a coordinate is going to be divided by 2. All right, so I've remembered sine of 30 degrees, or pi on 6, is a half. Then I've remembered everything's on a 2. Okay, now you can think about this 1 as the square root of 1, can't you? Because it's still just 1. And then you go 1, 2, 3. And there's your signs. And then you go 1, 2, 3 again. 1, 2, and 3. And there you go. That's how I memorize it. 1, 2, 3. With this root 2 on 2 business, that's the same as 1 on root 2, and often gets written this way. Doesn't have to, though. You can write it as root 2 on 2. Why are they the same thing? Well, you think about this. It's like that 2 could be expressed as a root 2 times a root 2. Cancel to give 1. Okay. Anything else I'd like to add? Oh, probably worth mentioning working angles here. So that's pi on 6, right? And, pi on 6 radians. Sometimes people get confused and they're wondering to themselves, well, the equivalent point over here in quadrant 2, is it there? Or maybe it's here, because if I went up to this 90 degree, or pi on 2 radians, and then I just went another pi on 6, I'd be at that angle there, right? So a way that you can remember that it's actually 5 pi on 6, which has the equivalent points, is to think about the working angle down to the x, right? Actually think about taking this angle. I mean, this is our starting point, but think about with reference to this horizontal here, this x. Okay, so the coordinates here, exactly the same numbers, root 3 on 2 and a half. Well, not quite exactly, are they? Because over here, right, if I was to give this coordinate its proper label, we're in negative x here. So that is a minus root 3 on 2. Some teachers like to draw the bow tie or the butterfly. Try and set this up. So where are, in all 4 quadrants, where are these equivalent points? And so over here, got negative x's, negative y's. Same numbers though, root 3 on 2 and a half. Negative. Over here, x is positive now, y is a negative. Right? Numbers are the same. And I've made this beautiful bow tie shape, if you will. Colour it in. It's like the big hungry caterpillar. It's eaten all the fruit, And now it's become a beautiful butterfly. Or is it still in its cocoon? Okay. Yeah, not too bad. All right. So hopefully that was helpful to some of you that are struggling to memorize. If you can count to 3, that sounds a little patronizing, but you know, it's not too hard to memorize. 1, 2, 3. 1, 2, 3. There's a pattern that should stick out. And for me, it's just about remembering a starting value. So for me, I've just got it locked away in my head. Sine of 30 degrees is a half, or sine of pi on 6 is a half. And from that point, all the rest follows. All right. Thanks, guys. Good luck with your unit circle.